So, well, growing up, I grew up in the eastern part of Uganda, where, of course, agriculture is the core of many families. And well, they don't even have a lot of land, but it is really subsistence farming. Personally, at home, we seldom bought food from the markets. We always grow our own food at home, but just enough to feed us, not even to sell, just enough to feed us. And so I grew up going to the farm, helping my parents with work here and there. We grew cassava, groundnut, beans, potatoes. We grew all of that stuff to eat maize. But growing up, I always wanted to be a doctor. I wanted to do cardiology. And at the end of the day, what I wanted to do at the bottom of my heart was to be able to change a life, to be able to cause impact, to be able to make someone's life better in one way or the other. So when I was able to interact with the different farmers and how they were making a lot of money from, planting these groundnuts on acres, foundation seed, or these really nice success stories. And I'm like, wait, this is an entire livelihood. Yeah, this is an entire, someone's life can basically be changed. The day you decide to do this, release a variety, people are going to have more yield on their farms. They're going to be able to have enough yield that they're able to sell part of it, even though we're dealing with small scale farmers. And at the end of the day, someone's life is going to be changed. They do not need to be in a hospital waiting for people to get sick to be able to cause an impact. Yeah. GRD is like the biggest biotic constraint in sub-Saharan Africa. And like you said, if the farmer does not have this resistance in the background, you're typically wasting time. So in certain areas across the continent where the pressure is a bit lower, maybe they can plant some of these susceptible varieties and get something out of it. For us here, especially in the first season, the farmers will get nothing, totally nothing. So it's important that we address these constraints. And most importantly, if we use molecular markers, if we are able to develop these molecular markers, okay, and we are able to track this resistance, then it means that we shall be able to focus on other important traits, because then we shall be able to select for groundnut rosette disease resistance as early as 2 weeks when the plant is just, getting out from the ground, which is, I think it's really a great thing. So we are having the diversity, we're exploiting the diversity to actually be able to address some of the really, really big constraints that we are facing. So I must say that I've really got really good results, because across 2 seasons and even across 2 locations, the results are consistent, okay? You plant the population twice and you're getting that the resistance is actually on 2 chromosomes consistently. On 2 chromosomes, and it's about the same chromosome, but on 2 different subgenomes, okay? So when I went on to dig in and look, I actually found a resistance gene that is involved in that particular region where the SNPs are found, and also another gene that is from the agonawide family, which is known to silence the virus RNA, okay? So I actually identified another gene that actually plays a significant role in gene silencing. And that is the best way that the genes can actually be able to respond to viruses by stopping them from multiplying when they get into the cell. What I'm doing right now is working with Josh and Damaris to be able to develop molecular marker assays that we can actually use to track these particular genes. Okay, and if we are able to develop these assays and we find that they can clearly distinguish between the resistant and the susceptible lines, then that actually means that we can actually make these markers very available even through the public Intertech platform. And that would be for every breeder around the world to be able to use, which is really, I think, a great thing. I think we're really close. I think we're close.